Hello. Um, we are we are studying the binary dependent variable models. In the last lecture, we learned two different models. The first one is the linear probability model, which is pretty much exactly the same model as the linear regression we learned in the earlier chapters. But the only difference is the interpretation when the dependent variable is binary, when the outcome is binary, then the expectation, the predicted outcome must be interpreted as the predicted probability of the outcome equal to 1. So the outcome is always 1 or 0, and we are estimating the probability that the outcome equals to 1. So that is the interpretation of linear probability model. So we call this linear probability because the probability is estimated by a linear function, which causes many problems. First, it goes beyond 0 and 1. Probability, by definition, must be always in between 0 and 1, but also linear function by construction will at some point go beyond 1 or go negative in some point. So linear function does not work well with probability estimation. So it has to be modified to fix this problem, which is uh, done by doing this way. So consider a curve that squeezes the linear function back into 0 and 1. So so it does so depending on how you make the curve, there are several different models, but what we are doing here is the probing model because this smooth curve is actually the standard normal distribution function. So we use standard normal distribution function, and to help your understanding, what we are doing here is we first calculate the z value. So think about the example of mortgage application. So you, you are you applied for a mortgage, and the bank decides based on your PI ratio. X is your say income or PI ratio. Say simply income. Then based on your income and other observed characteristics, in the first step, the bank grades your application. How good you are, how reliable, and that is called z value. Of course, it is just a hypothetical process, and it facilitates this analysis, this kind of analysis. So we assume that there is a z value as a linear function of x, which is related to the probability. And then based on the score, the grade, this linear grade, they calculate the probability of your application denial. The probability of denying your application is based on your grade. If your grade is high, you are more likely to be denied. So in this case, you may take negative sign. Anyhow, higher grade implies more denial, and lower grade implies less denial probability. So this is how we, and then as a result, you will get this predicted function. The probability is predicted this way. As the income as the income increases, income decreases. Higher PI ratio means lower income. As PI ratio increases, the denial probability smoothly increases, but it never goes beyond 1. That is how what we do in the probing model. uh, and like standard normal distribution is used here, and it it had so its implementation is pretty simple. Uh, there is no difference. Virtually, there is no difference from regression. So you can do the same thing. And the table, reading this table is, you can read the table in the same way. There are some differences here. So, but number of observations, it is exactly the same number of observations. And you see some unknown guys here. Don't care, like you don't need to mind them now. Just I think we do not study them in this course, so don't worry about this for now. Um, and then what's important here is, so it is nice we made a better probability predictor, but the problem here is it. So the linear regression was popular because it is very convenient to manipulate, to estimate, to interpret, and to get some results. However, probing model requires additional care when you when you when you predict the probability and when you calculate the effect of regressor on the probability, or the coefficients are more difficult to interpret. So I showed you an example that the probability is nonlinear, as you saw from the graph. It is nonlinear. It is flat, and then steep, and then flat again. So the increment, even if pi ratio increases in the with equal interval, the probability does not have equal interval. So probability increment changes at different points. So it's because of the nonlinearity of the model. Nonlinearity is the main problem. So I explained that. And mathematically, it is related to the differentiation. If you differentiate this nonlinear model, then by the chain rule, you get this. So beta 1 is the effect of the regressor on z value. So if your income increases, you will get a lower grade in the first step, and in the second step, lower grade decreases your probability of denial. So that is captured by this nonlinear function, and this is nonlinear. That's why this is the source of every nonlinearity. So this changes at different points. And then another problem here is the coefficient for the probing model is hard to interpret, and it's quite different from the linear probability model. Linear probability model's coefficient is only 0.6 something, but in the probing model, with the same data, the coefficient of the same variable becomes nearly 3, which is about 5 times larger than this. Why does this happen? The main reason is that the probing coefficient cannot be interpreted in the same way as the linear probability model coefficient is. So probing coefficient is an effect on the z value, not on the probability. So the coefficient itself does not have any meaning. It is not comparable to the regression coefficient. So we have to define the marginal effect, which calculates the final effect on the probability, so effect of x on the probability, which takes the same form. So change in x affects the z value, and change in z value affects the probability. So they are combined in one measure. That is the marginal effect. And the marginal effect is harder to calculate. First, obviously, because you need to know the derivative. And second, another problem here is, in the linear regression model, if the coefficient is 0.6, then always the effect of x on y is always 0.6 no matter what x is. So it does not depend on the value of x. The slope is always the same. However, in the probability model, as you see, the slope changes. So if you're here, your slope will be flat. If you're here, steep, and then flat again. Then as a result, you have to know where you are. You have to know if you are, so you need to know, if you are here or here or here. So an applicant who lies here has a small marginal effect, but on another or different applicant who's here will have a very large marginal effect. So the marginal effect can be different for different people, different individuals, different observations. So that also complicates the computation of marginal effect. We usually think about the marginal effect for an average person. That is maybe that is the most natural estimate of the marginal effect, but it's not easy to calculate. Oh, by the way, it's not easy to calculate by hand, but Stata does this for you, so don't worry about this. Today, we are going to consider an alternative to the probability model. There is very little difference. The only difference is that the probability model is based on the standard normal distribution. But now logit model uses logistic distribution function. So logistic distribution function looks like this. It is also like a nice looking, like this S-shaped curve, very similar to a normal distribution. But as you can see, it's much easier to calculate. So normal distribution function, standard normal distribution function, it's very complicated. So I did not, the slide does not have the functional form, but it has a much simpler functional form. So it's more it's better, it's efficient in computation. If you have a larger data set and many regressors, then the logistic distribution may work better. But in the end, there is no like a very little difference between probit and logit. So the idea is the same. Just in the first stage, you calculate z-value. In the second stage, calculate the probability based on the z-value. But the probability is now calculated based on the logistic distribution. Logistic distribution looks like this. So here, then why do we bother to consider the logit model? The main reason is historical. It is computationally faster. That's the main reason why we study the logit model. So now computation is not a problem. Like unless you have a super like huge data, but in the past, in the old days when the logit model, the probability model was first invented and developed, then computation was a big deal. You had to make a model which is tractable because you don't have computer at the time. So and then logit model had a huge advantage in that dimension. So that's why the logit model is so popular, and it is still popular because it was popular. So people use what they used to use. So it's still popular, and but in practice, virtually there is no difference. So if you use the logit model, then it's hard to criticize. So no one will criticize you why you are using the logit model, not the probability model. It doesn't make any sense. Like vice versa. If you use the probability model, and then no one is going to ask you why you did not use the logit model. That does not make much difference. And implementation of the logit model is also the same. just replace this part, this command, from regress to probit to logit. So logit model uses the then robust option works the same. Result table look the same. So everything can be done in the same way. And this is the result. So probit model, I don't know, probit is blue and logit is black, I guess. Anyhow, the result is like pretty much identical. So there is no meaningful difference between the probit and the logit, but both are widely used. So you need to know what they are, and you just need to know the uh, basic difference between them. So and they work in the same in the same way. So you just need to understand one of them, then the other is the same. At this level, of course, if you go deeper, there may be more differences. But like say, nonlinearity of the probit model holds the same way. It applies to the logit model, and the marginal effect calculation of the marginal effect is also applicable to the logit model. So these properties most properties are shared by these two models. So I'm not going to repeat that. Okay, I will stop here. Thank you for watching. See you later.